Now let's look at the third rule, the sum and difference rule. So in your question, you will see two functions of x. They will either be added together or one minus the other. So u and v are both functions of x. So it can be fx and gx. So when they are added together, you will see your question u plus v. So to differentiate this, we have to differentiate u, add, differentiate v. So that is the sum rule. For the difference rule, you'll see y equals to u minus v. So to differentiate this, we will have to differentiate u in front minus differentiate v and put at the back. Let's look at an example. So the first example, y equals to x cubed plus 4x squared. To differentiate this, dy over dx equals to, we have to differentiate this first, and we'll differentiate this with the power rule. Bring down 3. X remains, power minus 1 will be 2. So this is the sum rule. We'll keep the plus sign. Okay. And now we have 4x squared. So 4x squared, we have to use the constant multiple rule. So we'll keep the constant. Now we differentiate x squared, we bring down 2, x, and the new power becomes 1. So the final answer for this question will be 3x squared plus 4 times 2, 8x. Now let's look at the second example. So in the second example, you see a minus sign here, so we have to use the difference rule. So to differentiate this, very quickly, x cubed, differentiate, we'll have 3x squared, minus sign, we'll keep it. To differentiate 4x squared, will be 4, 2, x to the power of 1. So our final answer will be 3x squared minus 8x. So the difference between the sum rule and the difference rule is the sign in between. So the sign will follow the question. Now let's look at another less straightforward question. Y equals to a function of x multiplied by another function of x. How do we know we have to use the sum and difference rule in this question? We have to change the way it looks. So first I'm going to expand this. 1 times 1 give me 1. 1 times negative square root gives me negative square root x. Square root x plus times 1 give me positive square root x, and square root x times negative square root x will give me negative x. So I'm going to get y equals to 1 minus x at the end of the day. So this will be easier to differentiate. So dy over dx is equals to, now we differentiate 1, we'll be left with nothing. We'll differentiate x, we'll be left with 1. So the final answer will be negative 1. Let's look at differentiating 1. How did I get 0 earlier? So when we differentiate a constant, we will always get 0. If we differentiate 2, we will get 0. If we differentiate 100, we will also get 0. As long as it is a constant, we will differentiate it to get the 0. So this is something that you need to remember. Now let's look at x. When we differentiate x, we will get 1. Why? Imagine there's a power here, 1. We bring down the power, x remains, and the power minus by 1. Oops. Let's try to erase this. Minus 1. So we have 1x to the power of 0, which gives us 1. Let's look at another question. This looks like a fraction, but what we can actually do is to separate it out so that we can solve this using the sum or difference rule. So this fraction shares the same denominator, x. To separate it, my numerator over x plus the other number over x. So I get y equals to 9x squared over x plus 1 over x. Simplifying this, I'll be left with y equals to 9x plus 1 over x. So now we can work on differentiating this instead, which is much simpler than the fraction you see on top. So to differentiate this, I'll have to differentiate 9x first, which will give me a 9 using the constant multiple rule. I'm keeping the constant, plus 1 over x can be written as x to the power negative 1. So when I differentiate this, I'll bring down the power, x stays the same, negative 1 minus 1. So when I differentiate 1 over x, I'll be left with y minus 1, x to the power negative 2, which is negative 1 over x squared. So the final answer will be 9 minus 1 over x squared.